So in this problem, we want to find the absolute maximum and the absolute minimum of the function f of x over the interval from -4 to 4. It's a closed interval, which is important, meaning it includes the endpoints, and indicate the x values at which they occur. Okay, so we're going to need to find critical values because absolute extrema occur at either critical values or, if you're on a closed interval, at the endpoints. So we're first going to find critical values, so we need to take the derivative. We're going to have to use the quotient rule for this. So low d high, derivative of 3x is 3, minus high d low, all over the denominator squared, low. Okay, and let's simplify. So distributing, it's going to be easier to solve when we simplify first. That's why I'm simplifying. So distributing this 3 out right here gives me 3x squared plus 27 minus the second two factors over here combined to 6x squared. There's no need to FOIL the denominator. In fact, that would make it harder potentially later on. Okay, so the numerator simplifies to -3x squared plus 27, and the denominator is just x squared plus 9 all squared. So critical values occur when the derivative either equals 0 or is undefined. So we need to set this equal to 0 and solve. So to solve this, you would multiply both sides of the equation by the denominator, x plus 9 all squared. When you do that, it's going to cancel on this left side, so you'll just end up with the numerator. And 0 times this whole denominator is still 0. So it's essentially like you're setting the numerator equal to 0. Okay, then we want to solve this. So 27 equals 3x squared. So x squared is 9. So x would be positive or -3. Don't forget the negative when you take the square root of a variable squared. Okay, those are critical values. Then we need to look at where does the derivative not exist. Well, the derivative does not exist where its denominator equals 0. So f prime is undefined or does not exist where the denominator x squared plus 9 all squared equals 0, because that would give you a 0 in the denominator. Taking the square root of both sides, we get x squared plus 9 equals 0, so x squared equals -9, which has no real solution, so there's no critical values that come from where the denominator equals 0 or where the derivative is undefined. So the only two critical values are at -3 and +3, both of which are inside this interval from -4 to 4. So we're going to find the absolute max and min by plugging in the endpoints and the critical values into the function just to see which has the highest y value and which has the lowest y value. Okay, and this just takes a bit of plugging in, really. I'm just going to go put it into y equals 3x over x squared plus 9. Let's see. Like that. Oops. Okay, let's go to table set, ask, and table. Okay, so I'm going to enter -4. We got -0.48, and let's arrow over. Yep, it's exact. So -0.48. A decimal is fine here. For one, it's an exact decimal, so exact decimals are generally just fine. But sometimes fractions are harder to compare to see which is the largest and which is the smallest. -0.5, that's a little lower than -0.48, okay? When x is 3, y is positive 0.5, and when x is 4, y is positive 0.48. Okay, so it looks like, let's see, the smallest number right here is -0.5, so that would be the minimum. And the maximum is going to be 0.5, which occurs at x equals 3.